Locations indicate real places around us, and so it often makes sense to visualize locations using maps, which are visual representations of area. Android provides mapping support through the Google Maps Android V2 API. This API provides several different kinds of maps, specifically normal maps, which look like traditional road maps, satellite maps, which display aerial photographs of an area, hybrid maps, which combine satellite photographs and road maps, and terrain maps, which display topographic details such as elevation. Android allows your application to customize maps in several ways. For instance, you can change the area of the map that's visible to the user. You can add icons called markers at specific places on the map, and you can add overlay images on top of the map. You can make the map respond to gestures, such as a 2-finger stretch and pinch to zoom, and a 2-finger rotation to rotate the map. And you can also have the map indicate the user's current location, for instance, by placing a special marker on the map. To display maps, your application will probably use some of the following classes. Google Map, which represents and manages the map itself. Map Fragment, which displays a Google Map within a fragment. Camera, which defines the part of the map that's visible on the screen and defines the viewpoint from which the user is seeing the map. And Marker, which represents icons, sometimes with pop-up windows, that indicate locations on the map and that allow your application to display information associated with those locations. To set up and run a Maps application, you'll need to take some extra steps. For instance, you'll need to configure the Google Play Services SDK. You'll need to obtain an API key that identifies your application. You'll need to specify permissions, settings, and the API key in the Android manifest.xml file. And then you'll need to add the map to your application. And these steps are described in more detail at the following URL. In order to use the maps, you'll need to include several permissions. You'll need the internet permission so that map images can be downloaded from Google Maps servers. You'll also need the access_network_state permission, which the Maps API uses to determine whether it can download data. You'll need the write_external_storage permission, because map data needs to be written to the device's external storage area. And you'll need the google.android.providers.gsf.permission.read_services permission. And that's so that the Maps API can access Google Web Services. And if your map needs to acquire location information, for instance, to display the user's current location, then you'll also need to specify either one or more of the access_course location and access_find_location permissions. Our next example application is called Map Earthquake Map. And this application acquires earthquake data from a server and then displays that data on a map using clickable markers. Let's take a look. Before I show you the Map Earthquake Map application, let me take you back to the lesson on networking. And if you remember, in that lesson, I showed you the networking Android HTTP client JSON application, which issued a network request for earthquake data from the api.geonames.org web service. And that request returned a list of earthquakes that had occurred in a particular geographic region, and then the application displayed that data in a simple list view. I'll now start that application so you can remember what its user interface looked like. Here goes. As you can see, the application gets the earthquake data and then presents it in a list view. Now this is certainly fine. The data I wanted is there on the screen. But the user interface isn't all that helpful to me. For example, I can't really visualize where on the Earth these locations really are. And I can't easily distinguish major earthquakes from lesser strength earthquakes. So let's now look at the Map Earthquake Map application. And we'll see the same data, but this time it's presented in a map. Here goes. As you can see, instead of a list view showing lots of text, the earthquake data now appears as a set of markers on a map of the world. The location of the marker tells us where the earthquake occurred, and the color of the marker indicates the magnitude of the earthquake. Markers that are more red in tone indicate higher magnitude earthquakes. Markers that are more blue in tone indicate lower magnitude earthquakes. And in addition, if I touch a marker, a pop-up window will appear showing the magnitude of that earthquake. Now let me zoom in and touch a few markers. Okay, let's take a look at the source code for this application. Here's the application open in the IDE. Now, I'll open the main activity. In onCreate, the application sets the content view to the main.xml file in the res/layout directory. Let's open that file now. And here you can see that the entire layout is comprised of a single fragment that is provided by the com.google.android.gms.maps.mapFragment class. Now turning back to the main activity, the application creates and starts an async task, which acquires the earthquake data in the doInBackground method. And then it parses it and then updates the map in the onPostExecute method. So let's scroll down to the onPostExecute method. This method begins by getting a reference to the Google map underlying the map fragment. Next, it iterates through the result data. And for each earthquake record in that result data, this code adds a new marker. And each marker is created by creating a marker options object and then passing that object to the Google Maps add marker method. And as we've seen with other APIs, the marker options class uses a fluent interface. And so the code first creates a new empty marker option object and then sets the marker's position by calling the position method. And then it tacks on the text that will appear in a pop-up information window when the user touches the marker by calling the title method. And in this case, the title simply displays the earthquake's magnitude. Now after that, the code sets the color of the marker by tacking on a call to the icon method, passing in the default marker, but setting its color to reflect the earthquake's magnitude. And finally, the code calls the map's moveCamera method to center the map at a particular location. Now to keep this example simple, I pre-computed the map center, but of course it would be much better and more robust to compute the center based on the actual data returned by the web service.